Okay, so again, we're going to have this big paragraph. The problem with the paragraph is obviously we have to interpret the information. There's also some of this stuff is going to be talking about the constraints, meaning our inequalities. Some of it is actually going to be about the objective function. So yesterday when we did it, I gave you like a separate sentence that you were to write the objective function. In the word problems, they've kind of chunk it all together. So you just kind of want to be careful that you don't use anything that would be in our objective function to write our constraints. So it says a furniture manufacturer can make from 30 to 60 tables per day, so that would be important, and from 40 to 100 chairs per day. It can make at most 120 units in one day. And then it says the profit, so it changes gears from talking about how many you can make of each type in total to talking about profit. Okay, the profit on one table is $150, and the profit on one chair is $65. How many tables and chairs should they make per day to maximize their profit? How much is the maximum profit? So I want you guys to get together with, again, a partner or a small group of 3 or 4, so anywhere between 2 and 4, but I want you working with someone. So if someone doesn't pair up with someone, we'll just put them together with the other people. I want you to try and write the constraints and the objective function. I don't want you to graph it yet, because if you're using pen and it's wrong, then we have to redo it. But I'm going to give you guys about 3 or 4 minutes to try and come up with our constraints and the objective function, then we'll kind of come back together. You can notice that the variables have been defined for us if you look at the graph. So x is the number of tables, and y is the number of chairs. So if you want to jot that down, x is the number of tables, y is the number of chairs. If that weren't defined in the graph, you could do it the other way. It doesn't really matter. Okay. All right, go ahead and get together. All right, who can give me one of their constraints? One of their constraints. Abby?
30 is less than or equal to x, which is less than or equal to 60.
Good. Now, if you didn't write it this way, which I think this is the easiest way when it says between 30 and 60, but you could say also x is greater than or equal to 30 and x is less than or equal to 60. So if you want to write it out with the word and, you are welcome to. But usually whenever they write it in this form, it's just easiest to think x is in the middle. Remember, these will always be less than. What's another constraint? Another constraint. Jade?
40 is less than or equal to x, which is less than or equal to 100.
Close. It should be y because of the chairs. Y is chairs. I think you had that right on your paper. Maybe you had them backwards. Chairs is our y. So 40 is less than or equal to y, which is less than or equal to 100. And then the last one would be, Austin? Good. I did see a couple of you with greater than or equal to, so be careful. At the very most, it can be 120. So it really is less than or equal to 120. Again, technically you should group these all together, but if you didn't, I wouldn't mark off. But that brace is used to kind of show that they're all the constraints at the same time. And then our objective function. Now, another way to decipher information for the objective function is used to maximize or minimize. So whenever you see that you're maximizing profit, anywhere you see the word profit, that's going to be in your objective function. Which I saw most of you getting this. The objective function should be 150x plus 65y. Okay. Go ahead and see if you guys can graph that and evaluate to find the maximum values. So for the maximum, we should be getting It occurs at 60/60, and the maximum profit is $12,900. So in the blanks, we would fill 60 tables, 60 chairs, and the maximum profit is $12,900. Now, I showed in 12th period yesterday, when you're evaluating, and you guys get to use a calculator, using the graphing calculator, and I've shown this before, you can use the second enter feature, which recalls what you typed the time before, to kind of shortcut the evaluation process. Let me hide some of this. So for example, when you're plugging in, 150 times 30 plus 65 times 40. Okay, and you hit enter to get your 7,100. Instead of having to type that all in again, you can hit second enter and it will recall what you typed the time before. And if I wanted to do the 30/90, I can just go change the 4 to a 9 and hit enter, and it will calculate that for me. So it'll just save you a little bit of time in terms of typing it in. If you don't like that, you don't have to use it. But I like to kind of show some shortcuts when you're doing graphing calculator to begin with. Okay. Now the last part of the question says, suppose the profit margin increases so that the profit of a table is 175 and the profit on a chair is 100. What will the maximum profit be? So what would I do to find out what the new maximum profit would be? What does this new profit margin represent a change in? In our constraints or in our objective function? Sam? The objective function. Remember, profit is what we're maximizing, which that relates all to our objective functions. You're writing a new objective function. P equals 175x plus 100y. Now, technically, you should check all of the vertices again. Okay, why? Well, let's suppose that this this decreased in value, or one of them changed drastically. One of the other vertices could technically be the new max. Okay, so technically you should test all 4. Okay, even though most of you will realize like some of them aren't going to work, but occasionally an objective function can have a subtraction, which will drastically change the profit or the revenue that you're looking at. So we would test all 4. It does, for this case, end up getting us the same answer, the 60/60. But there is the chance that the objective function is modified so much that it changes the final answer. And I'll just go ahead and tell you what these are to save us a little time. We would get 9,250, 14,500, 16,500, and 14,250. So you can see the max is still the 60/60 point. So what is the maximum profit? That would be $16,500. Okay. We have one more we want to do together. Again, the hardest part, and this one's more difficult, is we want to write the constraints in our objective function. So suppose you're selling cases of mixed nuts and roasted peanuts. You can order no more than a total of 500 cans and packages combined, and you can spend no more than $600. How can you maximize your profit, and how much is the maximum profit? So instead of giving you a big run-on sentences up here, they gave you a little chart with, first of all, how many cans are in a case, how many packages are in a case. They tell us how much we pay for each case and how much we sell for each case. Okay? And they give us the profit per case. So a lot of information. So I'm going to give you guys a few minutes. Try and write your constraints, which again, the constraints are going to deal with inequalities. So you're looking for keywords, at least, at most, less than, more than. Your objective function is going to be related to the profit. Okay? There is something given in this chart that is extra information, something that you actually don't need. So I'll give you a hint on that. So go ahead and work with your group, see if you guys can write your constraints. So you should have noticed that this was the extraneous information, how much you're selling them at. That was there to trick you. So you didn't need that part. While you guys are working on the graph, I'm going to graph it up here just so I have it on my video for anyone that doesn't watch it.
Because it's saying neither of them can be 0, would you still put like?
They can be 0, they just can't be less than.
Okay. Oh,
So yeah, they could, it's the equal bar, they
okay,
could technically be
so
0.
use that as a-
Uh-huh, yep.
Please excuse the interruption. With those students going on the youth traffic safety field trip, please report to the front lobby at this time. Thank you.
You will get like some decimals. You're still plotting the decimals when you do, if you're doing your intercepts. Some of you may have subtracted 12x divided by 20 and then just did slope-intercept. But for the first one, we should have got that our y-intercept was 25. Our x-intercept is 41.6. So when you do that, you are going to have to slightly, ever so slightly estimate where you're plotting that. So my line's a little big. So my two lines look like this, and I'm actually waiting to shade it till the end. Okay, I'm also technically saying that x has to be greater than 0 and y has to be greater than 0. So I'm shading less than this and less than this, so the final solution should be, whoa, too big. This part here. All right, now, what's the problem that we run into at this point? Abby, we have no idea what this intersection point is, right? It's in between a couple pairs. We do know what the other ones are, right? We have 0, 0. We have 0, 25. We have 25, 0. Now, mine actually doesn't look like it goes through at 15. Does yours look like it goes through at 15? On my paper, it does. Oh, it does. It does up here, actually. I'm sorry. You can see that it definitely does have a x-coordinate of 15. We just don't know what the y-coordinate is, right? At least if you drew it carefully. So because I see that this is at 15, that means that my x-coordinate has to be 15. I just have to find out what the y-coordinate is. So to do that, we can take 15 and we can plug it into either of those, right? Because that's where they both intersect, and solve out to find what the y is. So I plugged it into the top one. So off to the side over here, I did 12 times 15 plus 20y. Now, instead of having it less than or equal to 500, you're actually going to set it equal to 500. Now, let's suppose you did the graph and you really can't see that it goes through 15. Like, you don't understand at all where the points are. You can solve this system, create it into an equation. You're looking for the intersection point. How did we learn to solve systems of equations that were in standard form? What strategy would I use to solve this system? Would I use graphing, substitution, or elimination? Yes, you can solve by elimination. Okay, just like we did on our last quiz, if you really didn't notice like either the x or the y coordinate, you can solve this by elimination. You'll get an ordered pair. The ordered pair is where they intersect. So that's why we learned that section before this. But if you can identify the x or the y, then it's easier to just plug that in and solve. We should get that y is 16 whenever we multiply, subtract, and divide. Okay, and then of course we have to evaluate each of those vertices using our profit function, our objective constraints. While you guys are finishing that up, I'm going to bring around your homework.